MathWorks. Here's a brief introduction, and also for those of you who know about MathWorks, also you may be familiar that our software, and I'll come to the names of the software in a bit, basically MATLAB Simulink, is used by engineers and scientists to develop, design products that we use on a day-to-day basis, whether these are automobiles, commercial aircraft, smartphones, consumer goods, and many, many others. Next slide. In addition to the products that we use on a day-to-day basis, our software has been used to power technologies that we will see upcoming in the next few years as well. So whether it's in the realm of electrification, for example, with solar-powered vehicles, prosthetics, advanced prosthetics in the form of medical devices or limbs, autonomous systems like robots that are used for across multiple different applications, including space applications, and in the area of clean energy as well. So briefly, what does MathWorks create? What do we make? There are essentially a set of software, or basically a whole set of software that we create. The baseline, or one of the families of products that we have, or platforms, is MATLAB, which is a programming environment for algorithm development, data analysis, numeric computation, visualization, as well as Simulink, which is a block diagram environment that is used for dynamic system modeling, or modeling and simulation of dynamic systems. So engineers and scientists using our tools can design, simulate, and test their entire system using a platform like Simulink, and can develop their data visualization, data processing, AI algorithms using MATLAB. Now, in addition to these two platform products, can you just go back one? We have a whole set of toolboxes and block sets, which you can think of as application-specific libraries that augment our base platforms for various different applications, whether it's, in this case, for example, for something like computer vision, or also for signal processing. We have tools that enable customers to develop their radar processing, control design, and even finance-based applications. So there are multiple tools that we have that enable engineers and scientists to take these base platforms and use them or apply them in their specific application areas. So essentially, millions of engineers and scientists worldwide use MATLAB and Simulink. We have over 5 million users based in practically all countries in the world, over 180 countries. Over 100,000 businesses, governments, and universities use our tools, and all of the top 10 automotive and aerospace companies are customers of ours and use our tools. Keep going. So this is the brief snapshot of the various different industries in which our tools are being used to develop this systems in these companies. So whether it's from, as mentioned, aerospace, defense, automotive, then you can go through, it's listed alphabetically, but you can think of semiconductors, electronics, industrial automation, all the way down to also finance and biopharma type applications. So any place where there is a necessity to process data, understand data, visualize it, and develop a software-based system that runs on mathematical computations, that is where our tools are being used extensively in the R&D as well as in the deployment phases. Keep going. So today, specifically why we've come together is for the MathWorks Automotive Conference. This is the first time we're doing it in Chennai. As mentioned earlier, I'm really happy to see this great turnout here in this room, as well as in the other room where our customers are. we're very honored and pleased about the large turnout today. Specifically, when we went into COVID times, we had to go to a completely virtual platform for our events, and we did that for two or 3 years, basically 2020, 2021. In 2022, in the beginning, we still had a virtual expo, MATLAB Expo, which is one of our events, and we had a virtual MathWorks Automotive Conference worldwide. But when things opened up, we realized also, during that time, also that some things we cannot replace in the virtual platform. So the in-person interaction, the dialogue that we can have with our customers, getting feedback from them, really getting into a discussion on what is important for them is something that is missing in the virtual platform. And so we've augmented our virtual events also with the in-person events, where we are focusing them more, these in-person events, more on the dialogue. So very important today, I'll get into that, are the panel discussions, the technology showcase, where really we can foster the dialogue with our customers. And so coming to a couple of the trends, and I'll hand it to Rashmi. Maybe Rashmi, you can take us.
Today, we have a very clear indication in terms of what are the trends that are shaping the investments and, if you may say, the future of mobility, right? So as you can see from this, and what is popularly called as CASE, and there's ACES and so on, it's basically the connected, the automated, the shared, and the electric trend. And at MathWorks, we are happy to say that automotive is an important industry for us, and we are investing heavily in each of these trends, which can be seen in the talks that we have today. So we have 3 tracks in the second half. One will focus on electrification, one will focus on automated driving, and the third will focus on software-defined vehicle, and Prashant will speak a little bit to that. Added to the MathWorks presentation and the customer presentations as well, so it's not just MathWorks, but it's also customers who speak about how they use our tools. We also have demo showcases, not only again by MathWorks, but also by our partners. So that's a little bit about the trends and how we are addressing it today. Prashant, back to you.
Yeah, thank you. So the first keynote was by Ramamurthy Mani, who is Senior Director from our R&D, from our development team, based out of Natick, Boston, close to Boston, which is our headquarters. He's come down specifically for this. And he spoke to us about architecting software-defined vehicles through model-based design. Model-based design is the workflow that is enabled through our tools, MATLAB and Simulink. And essentially, software-defined vehicles is a key trend that is occurring within the automotive space, and which we are enabling through our workflows. Then we had Dr. Philip Jose from Mahindra Last Mile Mobility, who spoke to us about establishing a model-based system engineering workflow as a core part of the electric vehicle development process. And then I gave a brief talk on the usage of ChatGPT and large language models with MATLAB. After this, we actually have a panel discussion ongoing which is focusing on the transformative journey of software-defined vehicles together with model-based design, and we have key customers as panelists. And MathWorks, we have Vijay Alayan from my team who's moderating that discussion. So panelists we have is Mr. Bhupesh Tekade from Renault Nissan, Hariharan Lakshminarayanan from Stellantis, Dr.Manaswini Rath from KPIT, and Gerd Winkler from Vitesco. So you can see the diversity of the panelists, some being from India, some being from outside of India, but also the representation across different players or stakeholders in the automotive industry. We have OEMs, we have tier 1s, and we have engineering service providers as well. And it's important that all these elements, all these stakeholders come together, because they are part of driving the trends and driving the changes, the transformation that is required to bring the newer technologies to the market. Post lunch, we are dividing down into 3 tracks. There's a track on electrification, which Rashmi just mentioned is a key trend. Then automated driving is another key trend, and we have a track focused on that, and software-defined vehicles, which is the third key trend, or one of the key trends that we are seeing in the market. And in this, we have talks from MathWorks engineers, as well as from our customers, who are going to be talking about various different ways in which they have used our software for developing their applications. Post the Tea and Technology Showcase, we have a masterclass, 3 masterclasses, again subdivided by these 3 key tracks: electrification, automated driving, and software-defined vehicles. I'll leave time at the end for Q&A, so I'll just get through this and then. Briefly, I mentioned this already, but here were the keynotes that we had by Mani and Dr. Philip Jose. So Mani is from MathWorks, Ramamurthy Mani, and Dr. Philip Jose is from Mahindra Last Mile Mobility. And this was the talk on ChatGPT and large language models in specifically, I talked a bit about what ChatGPT and LLMs bring to the table, what type of functionality they bring, how engineers and scientists can use these to accelerate their development process and also empower the entire workforce, and specifically looked at several approaches to leverage large language models from within MATLAB. And here introduced the MATLAB AI chat framework. In the panel discussion, this is a brief snapshot of the panel discussion that is ongoing right now. As I mentioned earlier, this is the transformative journey of software-defined vehicles with model-based design. Vijay Leon, who is senior manager from the application engineering team at MathWorks India, is moderating, and here are the panelists, as mentioned earlier. We will keep moving. Now, very, very important in the entire ecosystem of not just automotive, but also in engineering, science, R&D, STEM, is that we have a very diverse workforce, and that includes gender diversity, but does not limit ourselves to gender diversity.